let's record. So we're looking at these. I've just taken these examples out of the textbook. So here we are. So we're about page 376. But let's go through some of these things. So the important thing for us is we're going to simplify the fractions completely, because we talked about it the other day that a rational expression is when you have a fraction, because a rational number is a number that can be expressed as a fraction. So what numbers are irrational, just out of interest?
Square root of 2.
Square root of 2. In fact, the square root of anything that's not a square number, right? Because it's got a square root of a prime number. So we know from our surd work that we can break them down into our prime factors. So we know that square roots apart from the square numbers. Any other numbers that we know are irrational? The most famous one being pi. Yeah. So those numbers cannot be written, as far as we're aware at the moment, as a fraction. Right? So they can be approximated, but not exactly. So rational just means we can have it as a fraction. So I'm going to ask you, it says simplify these fractions, but justify each step. So I want to know what it is you actually do. So do you know how to simplify 25 over 100? Tell me the answer. Say it again.
Divide each, the numerator and the denominator by
1 over 4 quarter. Oh, well, we also know that just from money. 25 cents.
25%, or yeah, 25 out of 100, yeah. Why am I allowed to divide by 25, top and bottom? So what happens? So we would say that this potentially could be, so sorry if I make a bit more space to explain this, well you're explaining it. So 25 over 100, you have split it into 1 times 25 and 4 times 25, right? So you've kind of got remove the common factor. What do you do then? Okay, they cancel each other out to become what?
1.
Okay, that's what I'm after. This bit here, all right, let's sort of, rather than just cross out, let's think about what we're actually, other things we can say.
25 over 25 is 1.
Yeah, so an equivalent, so we should say this, an equivalent form, right, is this. And we can also write that as 1/4 times 25 over 25, gives you the same answer, right? Same thing, which is the same thing as saying 1/4 times 1. Right, so I know we've discussed those things before. So they don't just disappear magically, you know. We could look at it in terms of slightly another way to consider it would be saying 1 times 25 is then divided by 4 times 25. Okay, we've got brackets because it's the whole thing, right? Yeah, that is like saying 1 times 25 divided by 4 and also divide by 25. Is that, can you see how that's the same thing? Happy with that? Or? So this times 25 and this divide by 25 basically undo each other, if you want to think of it in that term. So that's when people cross out like that. They're basically using this method here. They're saying, well, this divide by 25 undoes the multiply by 25. So we don't need it, basically says nothing. That's one way, or we can see that it's 25 is a second fraction, and that's the same as 1, so it has no impact. Okay? Alright, I think that aspect to it is all super important. So 45 over 75. The answer. Say again. Divide by 15. That's where you need to know your times tables. Because even with a calculator, you kind of like, unless you know what to divide by, you don't know. So 45 divided by 15 is
3 over 5.
yeah. 64 over 80. Well, I'm going to show you, do it in multiple steps. So if I know that's divided by 8, that's 8 over 10, but we then can go further and say
Divide by 2.
divide by 2 gives me 4 fifths. Okay. $91 over 105. Tricky one out, this one. What? So this is
91
where.
over 105.
What?
91 over 105.
Does it not simplify?
I'm trying to think.
Well, let's just think.
I'm trying to remember
what
whether
end-
this prime.
We've got to use our kind of multiplication facts here. What can you multiply by what and end up with a 1? Okay. Right? But is that in the
What?
form of
No.
no? Anything else?
One. 3
Times
7.
7. Yeah.
No, the only 9 times 9 is 81. Can't do it in 10. Can't do it in 11. Can't do it in 12.
13 times 7.
13 times 7. Does that work?
Yeah. Yeah.
Yeah?
Yeah.
So let's just check.
Okay,
13
1
times
and 5
7,
divided
that's
by 6.
70 and 21.
But
Doesn't it?
can 105 be divided by 13?
Can it? Ends in a 5, so 13 times 5 would be 50 and 50, that's not enough.
13 times 10 is over the top.
It's got to end in a 5. Doesn't work? Can't divide by 13 or divide by 7.
7 works.
15 times 7.
No.
Yeah.
What is it?
15 and
15 times 7.
Oh, yeah.
70 and 35.
105.
So it's that 7 one, isn't it? So we can divide by 7, which gives me 13 over 50.
God, that was a struggle for a second.
It was, yeah. But those are hard ones. They're the
Well,
ones
E
that-
is easy.
Okay, so let me ask you. Yeah, that's the
12A,
next step up.
3A, divide by,
What is it?
divide by 3A.
Divide by 3A.
3A. And that
Divide
would
by
give you,
3A, and we get
4A. 4A. It's 4A over A, then it's just 4A.
So if I did, so let me just write this out here, just so we've got this as a note as well. if I've got 12a and I divide that by 4a, if I say 6 divided by 2, another option is to say 2 times what makes 6, yeah? So I've got to split the 6 into, or something times 2. I'll do it that way round, yeah? So that would then be 3. So I would know that. So what I'm saying here is, what times 4a gives me the 12a?
Just 3.
Just
Because if you
3.
do 3a, you get 12a squared.
Exactly, yeah. So we've got to be careful there. So it's just 3 times 3 lots of 4a. So 12a divided by 4a is 3. So when we go up here, if we divide by 3a, that's not a problem. But we are left with 4 and 1. Or just 4. 15a cubed divided by 60a.
Yeah. No.
So this is where we could think of it in the other method, which is, if I've got a to the power of 3, but I'm going to divide it by a to the power of 3 is a times a times a. So if I then divide by a, I'm removing one of the multiply by a's, right? So this divide by a will leave it only as a to the power of 2. Yeah? And then 15 divided by 60. Divide by 5, okay. So if we divide that by 5, we get 3 and 12. Can I go any further?
Yeah, I bet 3.
Divide that by 3, so it's just a squared over 4. So yeah, it is divided by 15 to start with. Yes,
X
G
plus 1,
is
X
as
plus
simple as, yeah, this is a factor, isn't it? Like we were just doing with our rearranging equations. This means 3 multiplied by something else. That something else just happens to be x plus 1.
If you, like, well,
So
you,
we just, that, multiply by that, but then divide by that, cancels, and we are actually just left with 3 over 5. Yeah.
Mr. If you got, if you were saying that, if you say like got stuck, would you be able to, like, in a test, just set a value for x and then have, like, say if you made like x1, you'd have 2.
Let's just have a look at what you're saying. So, sorry if you want to write that. So we've got 3 lots of x plus 1 over 5 lots of x plus 1.
And if you wanted to make, if you're like struggling to figure out how you could simplify it, like theoretically, could you just set a value for x and then?
So you say, let's say
x equals 1.
1, okay? That would then give me 3 times 2 over 5 times 2.
Which gives you 6 over 10, which you can then just
Well, in this
simplify.
case, you wouldn't even do that. You would just say,
Oh,
oh, 2 and 2.
2 and 2.
Yeah, you can do that.
But you could do
I
that.
don't think,
Not
But-
really necessary.
It's not that, yeah.
Yeah, it's not necessary, because it just leads you back to, oh, well, why can I get rid of it? Because they're the same. Well,
Yeah.
if those are the same, then,
Yeah.
I just get rid of them. But, I mean, yeah, if that's something that you can use, then feel free to use it. All right, this one.
X minus y over 3x plus 1.
So the common factor, again, is x plus y. So this multiply by x plus y is cancelled out by a divide by x plus y. So we're just left with x minus y, no need for brackets anymore. And then finally, so we can get rid of the a plus b's, okay, the e plus f's, and that's it, right?
Yeah.
So we end up with c minus d in brackets. We still need the black brackets over g plus h. But of course, there is another thing we can do here, isn't there? We can now go, well, that g cancels with that g, and that h cancels with that h, so it becomes c minus d, because I can just ignore that negative sign. Good with that? Good with that? Please tell me you're not good with that.
Yeah. You can't just,
Makes no sense, right?
Yeah.
I've just done that.
yeah.
Not allowed to do that.
Because you can't just ignore the
No, well, exactly. The fact that, I mean, the only reason I say this is because I've seen it. Oh, that negative doesn't fall into my pattern, so I'm just going to pretend it's not even there. Alright, it's not right down.
In this case, it would probably be the positive doesn't fall into this pattern. It's already got two negatives.
Yeah, yeah. Ah, there you go, because two negatives make a positive, so there you go, I'm going to have C plus B. Sorted.
No.
That sounds good.
Yeah. Alright, so what have I done with those decisions? I've used the process of, well, I remember in maths what we did was if there was a letter on the top and a letter on the bottom, we could cross them out. Right? Rather than thinking, well,
If
there was a multiply by something on the top and a divide by the same thing on the bottom, I can cancel those two out because the multiplication division of the same thing is the inverse. This is not the inverse of this, is it? Adding h is not the inverse of multiplying by g minus h. So be very careful. I see this a lot in this topic when we're doing rational functions simplifying, that need to oversimplify. Okay? So remember, when you are doing these things, don't do things that you're not allowed to do. Don't do things that you don't have a reason for doing. Alright? So you can write your notes. Don't do this. Right.
We need a criterion on this. This seems so
Well,
hard.
this is simply the how do you simplify them.
Yeah.
Yeah. We need to. What do you notice though about all these ones?
They just.
Well, they do. They have like terms, but what's important about those like terms? They're all factorized forms. These are not factorized forms, but you have in your head been able to factorize it, haven't you? This one, you know you can divide by 25. All right? So these ones are in factorized form. Oh, sorry. These are in factorized form because factorized form means I know what one thing multiplied by another thing is. So this is the simple case where we've already got it all in factorized form. If, for instance, I were to write this one in a different way, all right? Let's do that. So x plus y, x minus y. Let's have a look what it would be in a different way. So x plus y multiplied by x minus y, and what was it? Over 4x plus y. So I often see this as well, where people have it in this form, which is great. Sometimes they even put it in this form, which we need to get to. Do this and then undo all their work. So if I were to expand the brackets, well, I'm going to do the easy bit for you, which is this would become 4x plus 4y. Yeah? What does the top become?
Yeah, that's all we need to see, then that something's gone wrong.
X squared well, yeah, I'm kind of doing that. Remember the smiley face and our eyebrows. So we've got a x times minus y, so minus xy, then we've got the plus xy, and then we've got the minus y squared, which could simplify to x squared minus y squared all over 4x plus 4y. What's this called, by the way?
Coordinate. Is that what you mean? Difference of two squares.
Do you remember having, we've got x squared minus 9, if I asked you to factorize that, it would be x plus 3, x minus 3, yeah? That's basically what we've got here. Right.
Wasn't it like different square ones?
No, it's difference of 2 squared. We can use that. We need to know that to be able to do the complete square. Right, now if I gave you that, alright, and said simplify it, no problem, Mr. Fox. There's an x, there's a y, 2 minus 2 is 0, 4 is 8. Got it, Mr. Fox.
That was nice, actually.
Yeah.
Not quite. Not quite.
I think it's correct.
You have to expand everything again.
Not expand everything, factorize it, yeah? We've just expanded it. Yes, because the only way we can simplify a fraction is if we know something times something is then divided by the same thing, right? This is not in that situation. This is something times something, but then we minus this. It's not in the correct form, right? You can't cancel something just because it's been subtracted in that way. It doesn't work, because minusing y squared is not undone by dividing by 4y's. This is not. I mean, you screw your eyes up and you go, that doesn't, as soon as I say that, you go, that makes no sense at all. It doesn't do it. But when you're in an assessment, it's all too easy to just fall foul and go, I'm not actually thinking about what's going on here, am I? Alright? So does that make sense? That we need it in factorized form. So, all of those ones, are you writing this by the way? Do I need to stop? No?
So this putting it in factorized form is where I'm going to regret asking.
Yeah, all of these are basically in factorized form. So, where does that lead us? Okay.
Factorize everything.
For each of these rational expressions, explain the steps needed to simplify it to the given expression. Should we do that?
No.
X, can you remember that for me? X squared minus 9, x minus 3. I think we've kind of already covered it for each of that.
X squared minus 9 over x minus 3 equals x.
X minus 3, yeah?
Yeah.
Well, let's look at how we would simplify this. So, cross the x, cross the 9, yeah, we know it's not going to be that. We need it in factorized form. So, the factorized form of this one, now this is called the So we know straight away, not even, I've got this one sorted, this is x plus 3, x minus 3, and underneath is now x minus 3. Okay. So it's just x plus 3. Next one,
That's
x
my
squared
favorite
minus
one.
9, x plus 3. Wow.
The exact same thing, it's now just going to be x minus.
Exactly, we get x plus 3, x minus 3 over x plus 3, right? We will cancel that one. Be left with x minus 3. So that would be the same thing. And then finally, x squared plus 3x over x plus 3. X squared plus 3x over x plus 3. Yeah, I know, Mr. Potts, I've done all these ones, and that makes perfect sense, but I'm going to go straight back to just crossing out the x plus 3's and leaving with the x. 2, yes, that wasn't there. There you go, Mr. Potts, find your x.
I mean, that's what the book says.
It's what the book says, my answer's correct, obviously not.
We need to find another way to get to x.
Factorize. Is there a common factor of 3? What's the only common factor? X. So x multiplied by what makes this? This is x times x, and this is x times 3. So if I take the x out, put it outside, I'm left with x and plus 3 all over x plus 3. Now
we do get x.
We do get x,
Wow.
but we've done it in the correct way. So I think you start to get that. Probably the important bit is the being able to factorize in the first place. Once we have it in factorized form, the simplification bit is easy, right?
Yeah. Maybe that's never.
That's on video now. All her subscribers are going to be.
I know.
Alright,
All
so
my subscribers.
have you written, can I move?
Yeah.
Alright, so
Might not have heard
basically, I'm
It's
going
kinda hard
to
to
take
see.
you back to. I'm going to take you back to the beginning.
I'll just
Which
give,
is
I'll just give my
simplify rational expressions and state the restrictions. So simplifying rational, we've got more work to do, but you get the idea. What's this state the restrictions rubbish?
We don't need it. Let's go and break early. X can be anything in this case, I think. Oh.
X can be anything. Awesome, Aiden. Brilliant answer. Shame it's wrong. What
Less than 0?
if x is equal to negative?
Yeah, now I see that, because then you times it by 0. And
You'll see that.
yeah.
If I said to you 3 lots, because you did this before, what if I just chuck x in and then I try and simplify? But let's say you happen to pick the wrong number. You go, alright, x is -1 plus 1 over 5 times -1 plus 1. That would be 3 times 0 over 5 times 0, which equals 0 over 0. So, this is an interesting one because we've got 0 over 0, which of course is equal to 1. Well, anything divided by itself is
It's
1, right?
We've
But
had this debate before.
We're not allowed to divide by 0. So, we've got some issues there. let's have a look at this one instead. Alright? Now if I look at this form of it, alright, x can be anything. Alright? But if I look at this form of it, can't be 3. Okay. We're happy that x can't be 3, right? Just doesn't it? We get 9 minus
0
9.
is there.
Yeah, we get that problem. Alright. But if I put 3 into there, it's 6. But this is considered the simplified form of this. Therefore,
In order to simplify, you have to have a
so you must have considered what the restrictions are
at the start.
at the start before you start talking about the simplified form. All right, because in all of these cases, x is not allowed to be
Minus.
x can't be equal to -3, but that's not a problem there. Right? In this case, again, x is not allowed to equal -3, but it is there. All right. So that's what we mean by state the restrictions, but you must state the restrictions before you do the simplification. All right. So should we have a look at this one? Can you remember it? Or do
I
I
can write it down.
Yeah, I've got it.
Write it down here, but write it. I'll zoom in.
Thank you.
So you need to write by your glasses. Yeah.
Take out x.
We can take out x. Yeah. So let's do that first. So we've got x times x squared minus 9x plus 14. Then we say, all right, now I've got a quadratic. Could I potentially factorize the quadratic? So I need two things that multiply to make 14, add to make minus 9.
Minus 2 and minus 7.
7 times 2 would give me, but that's got to be a negative. So that means both of these would have to be negative, and that sorts that out, because add them -7 add -2 does indeed make -9. So that would give me, we've still got the x on the outside, but now it would become x minus 7 and x minus 2. Yeah. Let's chuck that back up at the top. What is it? X times x minus 7, x minus 2. Alright. So, the first thing we're going to do before we simplify is state the limitations. So, x, we've already said, is not allowed to equal 0. Why? In this sense, why is x not allowed to equal 0? How can I see
Because
that?
everything will be 0.
Yeah, because this
Anything
x
multiplied
here
by 0 is 0.
basically specifies that if it's just x times anything, it's now quite easily to be seen. Alright? The next one here, look, states that x is not allowed to equal 7.
Ah,
See it now.
and x can equal 2.
And x cannot equal 2 in the last one. Yeah? X is not allowed to equal 2. Right? So just to show you, in the book, it actually says it like this. Does that make sense to you?
Yeah.
So x is not an element of 0, 2 and 7. I've just written it in that way. Now, we can simplify. So we can simplify to x.
leave it with the x outside the bracket.
Hang on. What would you want to do?
You can
Cancel
cancel,
those.
yeah.
Yeah.
And then my question was, would you be able to just expand back, or should you leave it with the x outside the brackets?
A very good question, and
It
the
doesn't matter.
answer is it entirely depends on what you want to be doing with it next. I would suggest that what's going to happen next is we're going to need to add, subtract, multiply, and divide algebraic fractions, just like you need to be able to add, subtract, multiply normal fractions, yeah? We can do 3/4 add 1/5 by messing around with it and adding them together, yeah?
Yeah.
Which means we can do exactly the same with these. So having it in factorized form is the most useful form. But if I were to just look at that, what would we miss?
The x can equal 7.
Yeah, that limitation. We would still have the x can't be 0. We would still have the x can't be equal to 2. Okay, but we would miss one.
And then in every case, the constraint will always be x can't be 0, right?
No.
If everything.
Because let's just give you an example to that. Is x always not equal to 0? That's the question. So let's say we had a factorized form where we had x plus 3 and we had x minus 2 and it was all over x minus 2 and x plus 4. What would that simplify to? Yeah, it would just be x plus 3 over x plus 4. What would the limitations be? X is not allowed to equal to 2 and x is not allowed to equal to. What if I did put 0 into that, Aidan?
0 minus 2 is 0 plus 4. So then minus a on the bottom.
Yeah, so if I put x equals 0 in, I would actually get
Minus 6.
0 plus 3
Oh.
times 0 minus 2 all over 0 minus 2 times 0 plus 4. So that is 3 times negative 2, which is negative 6, over negative 2 times 4, which is negative 8, which I am perfectly happy. So x being 0 is not a problem in that case. Yeah? So no, it's not true that x is always not going to be allowed to be 0. Okay. Alright. Any questions on that we've talked so far? Right, so for you, moving forward, we don't have any time today, but maybe we'll have a look. You can see from the practice that you're going to be doing, these ones are going to be super easy up to this point. Then we get to, you need to know how to factorize. Right? You'll notice that when it's x cubed, you've got an x common factor. You're not at this stage asked to factorize a cubic that you can't take an x out. That'll be next year or the year after. In more detail. All right. Yeah. So that's what you're going to be doing. You have 1 minute, I guess, now to.